Inside every human cell is a protein. Ancient, elegant, waiting. Scientists spent 40 years learning to hijack it. This is the story of how they did it, and what happened when one woman decided to take that science as far as it would go. Long before the first human walked the earth, the instructions were already written. This is chromosome 2. Buried here, in a stretch of DNA unchanged for 200 million years, is a gene called POMC, pro-opiomelanocortin. It sounds like a mouthful. What it does is something close to miraculous. POMC is what biochemists call a precursor protein, a master key, a single chain of 241 amino acids that, depending on where it is in the body, can become completely different things. In the pituitary gland, an enzyme called prohormone convertase 1 makes one cut, producing ACTH, the hormone that triggers cortisol release under stress. But in the hypothalamus and in the skin, a different enzyme takes over. Prohormone convertase 2, PC2, makes a different cut. It clips out something smaller, a 13 amino acid fragment, Alpha-MSH, Alpha-Melanocyte Stimulating Hormone. This tiny fragment, barely a whisper of a molecule, is the signal that decides how dark your skin is. Your entire skin color, encoded in 13 amino acids. In the 1980s, a team at the University of Arizona, led by Drs. Victor Hruby and Mac Hadley, were working on a strange hypothesis. What if you could pre-tan someone, give them a pharmaceutical head start on melanin production, so that by the time they stepped into sunlight, their skin was already primed to protect itself? The idea was elegant. The problem was practical. Alpha-MSH dissolves in the body within minutes. To make a drug, they needed something that lasted. The result was Melanotan 2, a synthetic cyclic analog of Alpha-MSH, engineered for the body's blind spots. First, the chain was cyclized, folded into a ring, making it resistant to the proteases that would normally destroy it. Second, a diphenylalanine residue was substituted at position 7. Diphenylalanine is the mirror image of a natural amino acid. The body's enzymes can't grip it properly to break it down. The result, a molecule that binds its target receptor more potently than anything nature produces. Nature's signal, re-engineered, amplified. Meet the melanocyte. There are roughly 1 billion of them in your skin. They don't fight infections. They don't repair tissue. They have one job: manufacture pigment and transfer it to their neighbors. On their surface sits a receptor that is about to receive a very precise message, MC1R, the melanocortin-1 receptor. When melanotan 2 binds here, it triggers a cascade that reads like the most precisely choreographed molecular relay race in biology. Step 1. MC1R activates adenylyl cyclase. ATP is converted to cyclic AMP. The cell's concentration surges. Step 2. Cyclic AMP activates protein kinase A. pKa, a molecular switch, has just been flipped. Step 3. pKa phosphorylates CREB, a transcription factor, a key that opens gene promoters. Step 4. Activated CREB drives expression of MITF, the master regulator of the melanocyte. Step 5. MITF switches on the pigment-making enzymes, tyrosinase, TRP1, TRP2. And Step 6, the step you can actually see, eumelanin floods the skin. Not the pale reddish-yellow pheomelanin of an ordinary suntan, but the deep brown-black eumelanin of the world's most deeply pigmented people. Sustained melanotan 2 doesn't just darken you, it shifts which type of melanin you make. The chemistry of your skin changed. But here is what truly interests the biohacking world. The melanocortin system doesn't stop at the skin. MC4R, in the hypothalamus, governs appetite. Activated, and hunger drops. Satiety rises. The same receptor drives sexual arousal. Bremelanotide became the first non-hormonal drug approved for female sexual desire disorder in 2019. MC3R mediates inflammation, suppressing pro-inflammatory cytokines, a potential anti-inflammatory tool that researchers are still unpacking. One molecule, one receptor family. It touches appetite, arousal, immunity, memory, and the color of your skin. That is an extraordinary pharmacological footprint. We have walked the entire pathway, from the DNA on chromosome 2 to the 13 amino acid fragment that carries the signal. Melanotan 2 is a key engineered to fit that lock more perfectly than anything nature designed. But knowing the biochemistry is only half the story. Because in 2017, a woman in Germany picked up that key, and she had no intention of stopping at a tan. Next time, the story of Martina Big, and what the science cannot change. Visit unbedsidemanners.com to discover more stories of medical mysteries and the humans behind the science.